an ellipse, we had two parabolas that were being run right at each other. Collision course. All right. Now, an ellipse, or a hyperbola, is the exact same thing, except they miss each other. Okay? They miss each other. They're back to back. We are going to do vertical ones as well as horizontal ones. On your Cat for to Make a Pair of Kitten Britches, you will see two sets of formulas for horizontal hyperbolas and vertical. Okay? And the first thing we're going to do is we're going to learn how to graph those. Finding the pieces is really the same as everything else. Once you find HKABC, you're just plugging into the formulas, which you see there on your formula sheet. So really don't have to learn how to do that. You just need to learn what the pieces are. Okay, the horizontal equation that you see on your formula sheet looks like that. The x is first. You kind of have to forget what I told you yesterday. For ellipses, there are certain rules. Well, those rules don't apply for hyperbolas. For hyperbolas, for a horizontal one, the x is first. And the a squared is first. A squared is not always bigger necessarily with hyperbolas. It is with ellipses, but not with hyperbolas. For a vertical hyperbola, the y squared is first, or the y is first, and the a squared is first. So a squared is always first with hyperbolas, whereas yesterday, a squared was always bigger with the ellipse. You have to be able to tell the difference between the two. Okay? If you have a hyperbola with an x squared starting it, that is horizontal. If you have a hyperbola with a y squared starting it, it is vertical. That's how you tell the difference. That's the only difference in those two equations that you see up on the screen right now. Okay, here's just a little primer on how you graph a hyperbola. This is just a very rough idea. Okay? You're going to start with a center. You're going to be given the center, which is HK. After you get the center, you're going to sketch out two asymptotes, which is a word you've heard before. When we graphed our logarithmic equations last chapter, they snuggled against an asymptote. Remember that on that x-axis? Which means it got closer and closer and closer. Well, today, we have two of those. They're going to make an x on your graph. Okay? Through the center. You're also going to plot two vertex points, or two vertices. This is just a rough sketch of what we're going to be doing. And then from those two vertex points, you draw two parabolas that converge to your asymptotes. So that's kind of a rough idea of what a hyperbola, this one would be horizontal, a rough idea of what a hyperbola looks like. There is one error up on the screen. In the bottom left, you'll see that my parabola is starting to pull away from the asymptote. That's wrong. It needs to converge to the asymptote. Snuggle. Okay, so I've fixed it in red. The center is right in the middle of the two asymptotes. It's the intersection. You've got your vertices, just like on a parabola. We have two of them, because those are two parabolas heading off in opposite directions. asymptotes, like I said. There are two of them that make an x. There are foci for the parabolas, which we won't usually graph those. We'll just find them if we're asked to. Or sometimes if we have to work backwards, if we're given the foci and have to find the equation, things like that. There are a couple other new pieces. Something called the conjugate axis. It's the distance from the one asymptote to the other through the vertex. It's a distance, kind of a scale for your hyperbola. So that's 2b, I believe, is the formula for that. Distance from one asymptote to the other through the vertex. Transverse axis is really, it's the distance from one vertex to the other. And that's 2a. So from one of the parabolas, vertex points to the other, that's the distance, that's the transverse axis. That's 2a. So those are kind of the pieces of the hyperbola. A lot of that stuff you won't see when you graph it. When you graph it, it'll end up just looking like this. All right, the graph is the brown thing up there. The asymptotes can stay, but they're not part of the graph. If Trevor graphed one on his calculator, I'm guessing the asymptotes don't show up. It's just two parabolas. All right, so now what we're going to do is we're going to graph one of these. I'm going to walk you through it step by step. X squared over 16 minus y squared over 9 equals 1. First thing we have to do is we have to figure out which type of hyperbola this is. Since the x is first, it's going to be horizontal. If the y was first, it would have been vertical. Since the x is first, it's horizontal. Okay. We need to find HKABC. So we really don't need C to graph it. I just always find all of them, just for continuity, for consistency. So looking at my equation, I just have x squared. I don't have an x minus something. So h is 0 and k is 0. A squared is always the first denominator when dealing with hyperbolas. So a squared is 16. That means a is 4. B squared is the second denominator with hyperbolas. So b squared is 9, which means b is 3. You'll notice at the bottom of your cat for to make a pair of kitten britches that we have a new formula for c with hyperbolas, and it looks exactly like the Pythagorean theorem. And so what we've got is, instead of subtracting the denominators like we did with ellipses, we're going to add the denominators and take the square root. So 16 plus 9 is 25. Square root of 25, our c value would be 5. So if we were asked to find the foci here, which is the only time you need c, in ellipses or hyperbolas, we're ready. Okay? So the plan is CVA. We're going to find center, vertices, asymptotes. Find the center, find the vertices, find the asymptotes. After that, the rest of the problem is you being an artist. Okay? You're going to get to be an artist. The center is HK, which is 0, 0. So I've made my red dot there on my graph. That's the center. That's where the two asymptotes are going to originate. We said this was a horizontal hyperbola, so we're using those formulas for a horizontal. The vertices, the formula I believe is h plus or minus a, comma k. So that's 0 plus or minus 4, comma 0. which I believe is just plus or minus 4, 0, right? 4, 0, and negative 4, 0. And so those two dots, if I plot them, are there and there. So our two parabolas that we're going to draw, if you remember my little sketch from last slide, they're going to originate from here and here. But the question is, do they go here or do they go wide? And our asymptotes are going to guide us. It's kind of like when you go bumper bowling. Okay, the bumpers guide your ball down to where it's supposed to go. The asymptotes are going to be your guide to where the parabola should be drawn. So to find the asymptotes, we look at our formula sheet. And for a horizontal hyperbola, your asymptotes slopes are plus or minus b over a. The slopes of the asymptotes. So that, in this particular problem, is 3/4. Okay? That's the slopes. There's two slopes there. 3/4 and negative 3/4. Plus or minus b over a using the horizontal.
Did I write the wrong one down?
No.
Oh, you're just showing me.
So from our center, the center, we're going to go up 3 over 4, rise over run, and make a dot. Should have made these a different color, but I didn't. And then I keep going. I make another dot. Just like I'm graphing a line. So you can see my line starting to form. And then I want to go negative 3/4, because that's going to be my other line. From the center. Okay, you can see my line starting to form. And if you plot a few out, you can see where your X is. And I'm going to make more dots, just so it's a little more bold. So using a slope of 3/4 up 3 over 4 and negative 3/4 down 3 over 4, I have my bumpers for my parabolas. Center, vertices, asymptotes. CVA. Sierra, is your middle name Valentine?
No.
Okay,
That'd
well,
be close.
okay, well, if it was, these would be your initials. Sierra Valentine Abbott. Okay, so anyway, now we have to graph our parabolas. And there's nothing fancy. You just freehand a parabola that goes from that vertex point and then goes to snuggle your asymptote. Yeah, so here's my attempt. Looks like that. And my other one looks like that. And there is the graph of the hyperbola.